There are two main types of aquifers: confined aquifers and unconfined aquifers. There are some other types of aquifers as well, but for the purposes of this class, we're really just going to be focusing on the confined and the unconfined aquifers. So I'm going to diagram both of those, and as I draw these diagrams and describe them, we'll also talk about some of the main parts of these aquifers. So we're going to actually start out looking at an unconfined aquifer. So in the diagram that I have here, we have the ground surface here, so little tree to indicate this is the ground surface, and then we have a bunch of sediments. In this case, I've drawn these as basically gravels, unrealistically huge gravels. That's not important, but they're clastic sedimentary rocks of some sort. Below this layer of clastic sedimentary rocks, we have another layer of clastic sedimentary rocks. In this case, it is shale. The shale here is important because the shale is going to be what we call the aquitard. An aquitard is a layer of impermeable rock, so water cannot flow through it. Remember that shale is made out of basically clay-sized particles, and think about what we use clay for in everyday life. So we use it for ceramics because it is impermeable. So we shouldn't be surprised that our shale is going to be our aquitard. Again, that is our impermeable layer here. And then the layer above it, which is this layer of gravel, is going to be our unconfined aquifer. So the whole layer is the unconfined aquifer. Whether or not it has water in it is not important in determining whether or not it's an aquifer. The only thing that's important in determining whether or not it's an aquifer here is going to be whether it has high enough permeability that when water gets into it, the water can flow through this body of water. And in this case, the way I've drawn it, it has pretty high porosity and pretty high permeability. So if we have water that falls on the ground here, so here's our little cloud, here's our rain, the water will fall to the ground and it will infiltrate through this area, and it will eventually get all the way down to the shale. The shale is impermeable, so once it gets to the shale, it's going to start filling up the spaces between the grains. So in the interest of time, instead of very carefully drawing all the spaces between the grains, we're just going to color this whole thing like this, even though, of course, the water is just in the spaces between the grains, not actually in the grains themselves. So now we have two parts of our aquifer. We have a part where the pore spaces are completely full of water. They are saturated with water. This is our zone of saturation. So the part where the pore spaces are full of water here, this is the zone of saturation. Above that, we have an area where the pore spaces have some water in them, but are not completely full of water. This is the zone of aeration. Note that the zone of aeration is an area not where the pore spaces are full of air, and it is not the actual air itself. It is just part of the aquifer where there's some water in the pore spaces. Oops, that should have been blue. So some water in the pore spaces, but the pore spaces are not totally full of water. And then we have the boundary between the zone of aeration and the zone of saturation. So the boundary between those two zones is called the water table. So this is the water table, which is really just the top of the zone of saturation, or again, you could refer to it as the boundary or the border between the zones of aeration and saturation. So again, this is called an unconfined aquifer because water that falls on the ground here will infiltrate directly into the aquifer. It does not have to go through some other area of unconfined, does not have to go through an aquitard or anything like that before it gets to this aquifer. So the unconfined aquifer is not separated from the surface by an aquitard. It is in direct contact with the surface. So what this means is that the water level in this aquifer is going to be a direct result of how much it has rained recently for the most part here. So if it rains more, then the aquifer fills up and the water table rises. If it rains less, then some of this water will be used, some of it might evaporate, and the water table will go down. So for the unconfined aquifer, again, it is in direct contact with the air surface here. If we were to drill a well then into this aquifer, the water level in the well is going to match the water level of the water table. So here, let's just say that there's a well drilled in here, and the well could be as simple as just a pipe pushed into the ground or dug into the ground, or even just a hole dug into the ground, really. Most wells are going to basically be a hole in the ground and then PVC pipe or some other type of pipe, and then the pipe is going to have tiny, tiny little holes in it. So if I were to just, let me do black for little holes through here. So if this was all these little holes, that would basically just allow the water to fill in the pipe as long as there's water next to it. So then the water here is going to, I'll choose a slightly different shade of blue. The water level in the well is going to be at this point the same as the water level in the aquifer. So if there's a drought and the water level goes down, the water level in the well will go down. If there's a whole lot of rain and the water level of the aquifer goes up, then the water level of the well will go up. So for an unconfined aquifer, the water level in the well is going to be the same as the water level in the aquifer. So wherever the water table is in the aquifer, that's how much water is going to be in our well. The next thing that we're going to look at is going to be the confined aquifer. So we'll add other layers in here to add in our confined aquifer. So we have to have another aquitard. So this is going to be another shale layer. And by the way, the dashes, this is the general geological symbol for shale. So it's actually the international symbol for shale. So on any geological map, if you see these dashes, that means it's shale. And then we'll just add in a bunch of other sediments here. For the sake of time, I'm not going to fill them all in. So now we have our unconfined aquifer in connection with the surface here, and then our confined aquifer here. So we can label this as our, actually we'll erase a little bit so we can make that label. So now we have our confined aquifer here. So what this means is that basically water that falls on the ground here is going to infiltrate into our unconfined aquifer here, but it will not get into the confined aquifer here. The only place where water can get into our confined aquifer is this one little section where it is in contact with the surface. Not every confined aquifer is going to have a place where it is in contact with the surface. So some confined aquifers are completely confined. In this case here, just as an example, I've drawn it as though there's some sort of fold in the rocks. This is not uncommon at all. Rocks get folded all the time. So in this case, these rocks are folded and they come into contact with the surface here. So we would say that this aquifer is unconfined just between these two shale layers, and then it is confined everywhere else. So this one area where water can get into our aquifer, this is called the recharge zone, or sometimes called the zone of recharge. It's the same thing. So the water level in this aquifer is going to be dependent on both the what's happening downstream. So if the water is flowing away from it, how much water is being pumped out of it and all that. And also how much water is getting into it through the recharge zone. So let's just say that the aquifer is filled up to something like here. So we'll just generally fill this in. I guess now we have kind of purplish water. I didn't really realize it was going to be that color, but that is okay. So this water is the same as the water in the unconfined aquifer. It's just in our confined aquifer here. Okay, so we have our water level something like this. If we drill a well into our unconfined or into our confined aquifer here, so let's say that we're going to drill a well into our confined aquifer here. We're actually going to drill 2 wells. And in this case, let's say that we know that there's some source of pollution in the unconfined aquifer. And so as a result, when we drill our well, we're only going to have holes in the well in the part that is in the confined aquifer. So no water can get into our pipe in the unconfined aquifer. The only place where water can actually get into our pipe is going to be here in the confined aquifer. So, what's the water level in our well going to be? This is an interesting question. And in this case, the water level in the well depends not on where the top of the aquifer is. Oops, let me undo that and go back to here. Not on the top of where the aquifer is, but in fact on where the top of the water level in the aquifer is. Because in this case, there's pressure pushing down on the water in the aquifer. So all this water at the near the surface or higher elevation up is trying to flow downhill. And so it's putting pressure on the water farther down in the aquifer. And when we drill a well here, it releases some of that pressure. And so the water level is going to come almost all the way up to the same level as the water level in the aquifer itself. It's actually going to be a little bit lower because some of the pressure is lost as we go downhill. But a lot of the pressure is going to push that water from the confined aquifer and then basically up this well here. So here's our pressure coming down and then pushing this water up the well like this. In this case, because this well is drilled into a confined aquifer, we call this an artesian well. So an artesian well is actually just a well that is drilled into a confined aquifer. There's nothing extra special about it. Often water companies, Fiji Water, for example, makes a big deal about, oh, its water comes from artesian aquifers. That really doesn't mean anything except it came from a confined aquifer. And while it is true that confined aquifers are less susceptible to waste or pollutants from the surface, there could just as easily be some form of pollutant in the rocks around it, or maybe there's another well that's somewhere over here and it's leaking material, although that would probably be going the other way. There could be lots of other sources of pollutants. So just because the water is coming from an artesian well does not mean that it is by default much cleaner or much better in any way than water from any other source. It all depends on the specifics of the area. So let's say that we also drilled a well into our confined aquifer a little bit farther down the hill. So in this case, the opening of the well is going to be farther down or farther downhill. So let's drill or draw our well here. Again, this is still going to be an artesian well because it's still a well that's drilled into our confined aquifer. Here's our little holes in the pipe to let water in. And then the water level in this well actually is going to be, again, at about the level of the pressure. So this is the pressure surface. We call this actually the artesian pressure surface. So that tells us about how high the water level in the well will be. So in this case, actually, the water level is going to be above the top of the well. So there's going to be so much pressure that it actually allows the water to flow out of the well. Okay, in real life, you'd probably cap it or capture that water somehow so it wouldn't all go to waste. But in our little example here, the water just flows out of the well like this. So in this case, we call it a flowing artesian well. I'm just going to, try to erase this little cloud just to make some more space for labels. So we are going to call this a flowing artesian well. There's nothing, again, extra special about it. It just means that it just so happens that there's enough water pressure in this pipe that it gets forced all the way up and out of the pipe. If the water level in the whole aquifer decreases, so let's say that the water level drops down to here, well, in that case, the water level in our artesian well would be here, and it would no longer be considered a flowing artesian well. So just because it's a flowing artesian well at one point in time does not mean that it will always be a flowing artesian well. So that's a little bit about our unconfined aquifers that are in direct contact with the surface, and our confined aquifers, which are separated from the surface by an aquitard. So they are separated from the surface by an impermeable layer.